Hey guys, welcome back to ThinkTech. So in the first part of this video, we understood the theory behind linear regression. So if you have not seen that video, please go and watch that video before you continue on this one. You can find the link in the I button above. So in this video, we'll do a code walkthrough of how you can implement linear regression using PyTorch. So let us get started. So this is my Jupyter notebook where I've created a very small implementation of linear regression. I have not used any library, so everything I have coded by hand so that we understand the workings of how linear regression actually works as well. So the first things first, we import the libraries that we are using. So this is just simply importing of PyTorch, NumPy, Pandas and matplotlib for plotting our data points. The next thing is I have created a sample data set. So these are some points that I have randomly created. You can use these points, you can like code these points like this, or if you have, more often than not, you will have a data in a data file. So you can write a simple code to just read that file either in CSV format or whatever format it is and load it into, using NumPy, load it into a variable. Now I have segregated the x and y coordinates into two different arrays and I have done a scatter plot. So this is how the plot looks like. There are fairly few points which are in the upper half of this plot and few points which are in the lower half of this point. Now let us go to our linear regression implementation. So as we discussed, there are two parameters in linear regression. One is the weight and bias. So I've initialized both of them to 0. Initialization is again something that there is no one correct answer to initialization of parameters, but generally we tend to initialize the parameters with 0 itself, but you can try with other values as well if it suits your use case. Then L is the learning rate. This again is something that we discussed. Learning rate I have kept to be fairly low. This again is something that you can modify by fine tuning. And epoch is again a very common term that is used while deep learning. Epoch is the total number of iterations that your model will make of the entire training sample, right? So I have chosen epoch as 1000 iterations, and then n is the number of points that I have, right? So this is the number of coordinates that we have. So simply what we'll do is we'll start with the for loop. The first step in the for loop is to make a prediction, and this is exactly the linear regression equation that we discussed, which is y hat is equals to weight tensor into input plus bias, right? So this is your predicted output, and then we will calculate the loss. Now you can calculate the loss or you can directly calculate the derivatives, because ultimately that is what the loss is being used to calculate. So as we saw that the derivative with respect to w is minus 2 times the multiplication of the input tensor into the difference between the actual label and the predicted label, right? So you can go back to that slide where we hand derived these derivatives and see that this is the exact equation that we derived in that case also. And next is your derivative with respect to bias, which is minus 2 times into sum of y hat minus the predicted value, right? Y minus the predicted value, which is basically actual value minus the predicted value. I think this is why you are seeing a negative sign here, whereas in the derivations you will not see a negative sign, but here we have replaced this, we have flipped these values, that is why there is a negative sign. So both of these implementations are correct, both of them you can try. Now comes the second part of that discussion where we talked about how do you update these weights, right? So W and B were your existing weights. You have calculated the derivative of the loss function with respect to W and B. Now you have to update these parameters. The update equation is existing weight minus learning rate into the derivative with respect to that parameter. So for W it will become W new will be equal to W old minus the learning rate into the derivative with respect to W, right? Similarly for bias new will be equal to bias old minus learning rate into derivative of loss with respect to the bias, and these becomes your new parameters which are now used for making new predictions, right? So this is a very simple implementation. This is how you can implement linear regression just by these 5 lines of code. Now if I run this, part, you will see that the after 1000 epochs, the weight and bias which is giving the lowest loss, or which is giving the lowest loss after 1000 iterations, is this. W is 0.408 and bias is 3.16. So now your linear regression equation, the line equation that we were discussing, becomes this, which is y is equals to wx plus b, right? So this becomes your equation. Now let me plot this line into a scatter plot and see how the distribution of the points are with respect to this point, this line. So this is the line that we have predicted, and you can see that it fairly divides the entire sample size that we have. So there are about 1 2 3 4 5 6 7 8 points on one side of the line, and 1 2 3 4 5 6, I think 1 2 3 4 5 6 7 8 9 points on the other part. So this is a very good division that this line is able to find. Now since it is a linear equation, it will not be able to learn more complex patterns or learn subcurves or something like that. This is the best linear fit to the data, which was our goal. This is the best linear fit to the data that we have been able to find, right? So I think, yeah, this is it. So this is a very simple implementation of linear regression. You can use this code for implementing linear regression for your own data sets. You can try things that you can change is the initial value of W and B, the learning rate, the number of epochs that you train on, and you can run this code and create your own linear regression model that suits your dataset. Thank you so much for viewing this video. Please do not forget to like, share and subscribe so that everyone else who wants to learn about these topics can also take benefit from this video. Thank you.